So what if I told you that every single decision a computer makes, I mean everything from a simple calculator app to the most complex video game logic, really just boils down to a handful of simple symbols? That's what we're digging into today. C operators. These are the absolute fundamental building blocks we use to tell a computer what to do. Let's get right into it. Okay, let's kick things off with a big question. When you see a program react to what you're doing, or choose one path over another, how is it actually thinking? I mean, how does it make a decision? It can feel like some kind of magic happening behind the screen, but the secret, well, it's surprisingly simple.
And here's the answer. It doesn't. A computer doesn't think at all. Not in the way we do. It just follows our instructions with perfect, lightning-fast obedience. And our job, as programmers, is to give it those instructions, using this special vocabulary of symbols, which we call operators. You can almost think of them as the verbs of the coding world. They're the action words.
So where do we start? Well, let's start with a language we all learned back in school. The very first set of operators you'll get comfortable with are just for doing basic math. Because at its heart, a computer is just a very, very fast calculator. Now, most of these are going to look super familiar. You've got plus, minus, multiply, and divide. And they do exactly what you'd expect. The one that might be new to you is that little percent sign. It's called modulo, and it's actually a really handy tool that just gives you the remainder of a division. So, for example, if you do 10 divided by 3, you get 3 with a remainder of 1, right? Well, modulo just gives you that 1.
And here's what it looks like in a real piece of code. This line is super straightforward. It's just telling the computer, hey, take the value you have for A, add the value you have for B, using that plus operator, and then just print out the result. See, it's simple, it's direct, and it's incredibly powerful.
Okay, so doing math is great, but the real power, the real magic, comes when we teach the computer how to compare things. This is how we start building actual decision-making into our programs. We're going to use a new set of operators to ask some simple yes or no questions.
So this right here is absolutely critical. I need you to notice the double equal sign. In C, if you use a single equal sign, you're assigning a value, like saying x equals 5. But when you use a double equal sign, you're asking a question. You're asking, hey, is the value of A the exact same as the value of B? That difference is one of the most important things to remember.
And of course, the opposite of is equal to is not equal to. For this, we use an exclamation mark right before the equal sign. A good way to remember it is to just think of that exclamation mark as meaning not. Is A not the same as B?
And the rest of these comparisons are just as intuitive as you'd think. We've got greater than, less than, and, importantly, their or equal to versions. These operators let our code understand the relationships between numbers, which is the foundation for, well, pretty much everything from sorting a list of names to creating the boundaries of a level in a game.
And this is the whole point. This is the magic. No matter what question you ask with these relational operators, is it bigger, is it smaller, is it the same, the computer's answer is always one of two things: true or false. That simple, binary, yes or no answer is everything. It's the signal that lets our program make a choice to turn left instead of right.
Okay, so now we know how to ask a single yes-no question. But what if we need to create more complex rules? For that, we need logical operators. And a great way to think about this is to imagine a bouncer at a club who has a checklist for letting people in.
Our first one is the logical and we write it with 2 ampersands. Now, the and operator is really strict. It's the tough bouncer. It demands that the condition on its left and the condition on its right are both true. If even one of them is false, the whole thing is false. No exceptions.
So here's our bouncer logic in action. The code checks 2 things. First is the age 18 or older. Let's say, yep, that's true. Then it checks the second thing, do they have an ID? Let's say that's also true. Because, and only because, both conditions were met, the person is allowed to enter. Next up, we have logical OR, which we write with 2 of those vertical bar symbols. Now, the OR operator is way more relaxed than AND. It's the chill bouncer. It only needs one of its conditions to be true for the whole thing to be true. This example for getting a discount is perfect. To get the discount, you either have to be under 18 or you have to be a student. You don't need to be both. So a 25-year-old student, yep, they get the discount. A 16-year-old who isn't a student, they get the discount too. As long as just one of those things is true, you're good to go.
And finally, the simplest of these 3,
the logical not, which is just that single exclamation mark again. All this little guy does is take a true or false value and flip it to its exact opposite. If a condition is true, putting a not in front of it makes it false. It's literally just an inverter switch.
All right, we have totally covered the core logic. Now let's look at a few operators that are kind of like pro tips. These are shortcuts that let you write faster, cleaner, and just more efficient code once you get the hang of them.
Okay, first up is one that can be a little tricky at first, the post-increment operator. When you see a variable with two plus signs after it, it means two things are about to happen in a very specific order. First, the program is going to use the variable's current value for whatever it's doing. Then, after that's all done, it will add 1 to the variable. The order is everything. Use it, then change it.
Let's break that down with an example. If a variable a is equal to 5 and the code says to print a++, it's going to print the number 5. As soon as that print is done, the value of a stored in the computer's memory quietly becomes 6, ready for the next time we need it. You see this all the time inside of loops.
And its partner, as you probably guessed, is the pre-increment, where the plus signs come before the variable. This just flips the order of operations. First, the program adds 1 to a, and then it uses that new updated value. So if a is 5, plus a immediately makes it 6, and the number 6 is what gets printed or used in the calculation.
Now for a real fan favorite, the ternary operator. I know it looks a bit weird with that question mark and a colon, but it is an unbelievably elegant shortcut for a basic if this, then that, otherwise this kind of decision.
And this slide just says it all. Look at the difference. On the left, you've got a standard 4-line if-else block just to find the bigger of two numbers. On the right, the ternary operator does the exact same job in one single clean line. It's not just shorter, it almost reads like plain English. Is A greater than B? If yes, use A. If no, use B. It's brilliant.
So let's do a quick recap of our programming toolkit. We started with the arithmetic operators for doing all our math. Then we moved on to relational operators for asking those basic yes or no questions. After that, we used logical operators to combine those simple questions into complex rules. And finally, we looked at a few clever shortcut operators to keep our code tight and efficient. You know, these operators really are like the Lego bricks of programming. By themselves, they are so simple. A plus sign, a greater than symbol, a couple of ampersands. But when you start combining them, you can build literally anything from a simple calculator all the way to a massive video game. The only real limit is your own logic.